In this lesson, I will explain to you the concept of support vector regressor. Before going to start, I will explain to you the difference between support vector machine and support vector regressor. As you know that in machine learning, we have learned supervised learning. And in supervised learning, you know now very well that it deals with the regression problems as well as the classification models, right? If we are working or we are making the classification model, then you have to use SVM, right? While SVR, if we deal with the regression problems, then we should use SVR. So simply you can say that SVM or SVR supports supervised learning, under which we learn regression and classification. Suppose we have two different kind of cells, benign cells and the malignant cells. If a new cells come, so this is called the classification model, that whether this cell belongs to this group or this group, then we have to use the SVM. Now is support vector, sorry, this is called the support vector regressor, and this one is the decision tree regressor and random forest regressor we use for non-linear data. Right here I have written as well non-linear. Actually what happens in regression, suppose these are the points, so we try to make a line, right, which covers most of the points. Suppose this is the line, right, in linear regression. So this one is our actual data, and the points which appears on the line, these are the predicted line, right? So here you can say that this is the actual and actually this is the predicted. We have to find out the error, so these are called the error margin. This one is the error, this one as the error. So in linear regression, actually we try to reduce the error margin, right? While in this case, SVR or non-linear, we set a threshold or we set a boundary that our errors cannot go beyond these boundaries, right? So here we use for non-linear regression SVR, DTR and random forest regressor. We use these things we use for non-linear regressions, or simply you can say these are the algorithm for non-linear regression, right? Here in SVR we use the term kernel, hyperplane, boundary line, support vector, which we had discussed in my last lesson. So I will highly recommend, please watch that video, right? So here is the example of the higher plane. Suppose these are the data points in SVR. This is the hyperplane, this is the decision boundary, this is the decision boundary, means these points, data set or data points cannot go beyond these boundaries, right? Suppose if we have a data, how we know that this data is suitable for linear model or for polynomial model or for our SVR? So here is a simple example. Suppose these black points are the actual data set. If I will make a line, right, this one, the green one is the straight line, so you can see it does not cover too many points. It means linear regression is not suitable for this model or this data set. Then is our blue line. So see, this blue is a little bit curved, which is for the polynomial, which we already discussed. So this is not suitable. But here, this one, the red one is for SVR. Here we had used the kernel, and by the default kernel is RBF, radio basic function. How it works I will show you. And one more thing, that for non-linear regression, our line, our predicted line will not be in the straight line, it will be in the form of arc. So I have written some information that SVR uses the same basic data as support vector machine, a classification algorithm, but applies it to predict the real values rather than a class, right? So this one SVR we use for regression, and in regression we use the continuous variable, and for SVM we use the discrete variable. SVR acknowledges the presence of non-linearity. See, the focus is non-linearity. Our data will not be in the line, it will be in the form of curve or arc in the data, and provides the proficient prediction model. Same thing is written here, but the wording is changed. The basic idea behind SVR is to find the best fit line. Unlike other regression models that try to minimize the error between the real and the predicted value, as I have mentioned in the case of a linear regression, right? We try to minimize the error, but SVR tries to fit the best line within the threshold value. Simply for the threshold, you can say that we set the boundaries, that our error cannot go beyond that boundaries. The threshold value is the distance between the hyperplane and the boundary line. So this is the hyperplane and this is the boundary line. So I highly recommend, please watch my previous video. That will be very nice for you to understand the concept. Now we are going to start. Before going to start, I will show you the data. Data is available on our CSV file. This is my Excel file. This is the experience and salary. So see, salary is the dependent variable we take on the y-axis. Experience is the independent variable which we take on the x-axis. If you want to make just graph like this in Excel, so keep in mind, in Excel you have to select the data first, then you have to go to the insert tab in charts group, open this, and there are different kinds of these graphs. So whatever you want, see, if you will click here, only if you want dots, right? So this one, I actually had chosen this one for this data. So this data we are going to use to make our model for SVR, support vector regressor. So the libraries which we will use here, I have written here: import pandas as PD, import numpy as np, and then for matplotlib for graphing purposes, I am going to run this. Now the steps we will use in order to make this model. So first of all, we have to import our data frame. Our data is available in the CSV file. So here I will show you how to do it. And then we have to create two variables. One is for x-axis, one is for y-axis. So only we have two columns. Experience we will take on the x-axis and salary we will take on the y-axis. How? I will show you. Then from sklearn we have to import SVR, support vector regressor, right? And then from sklearn.preprocessing we have to import a standard scalar as well. Why we have to import a standard scalar, I will explain to you when we will come to that point. But first we have to import SVR, and after importing SVR, you know that we have to create the object. After object we will fit the model, predict and graph and check our score. Okay, let's go started. First of all, we have to import our data file. So wherever you have saved your data files, you have to bring it here, write down the path in quotation. And I said the name of all this line is DF, means data frame, execute it. So you can see experience and salary. Quickly, I will explain to you one more time that this is the index. System has generated the index which starts from 0 and so on. And these are the two columns. So you cannot say if I will ask you what is the index number experience, please do not say 1, 2, no. Index always starts from 0. So 0 means experience, 1 means salary. If we read from left to right, if we read from right to left, so it will be -1 and -2. From right to left, you do not have to start index by 0. 0 starts from left to right, right? This is the important point. And if you want to check the shape, means how many rows and how many columns you have in your data set. So 12 records and two columns. One is experience, one is salary. But here you can say that why it is 12, because indexes start with 0. That is why our last is 11th index. Actually, if you will count, there are 12 records. Now we have to make our x and y variables. So x is equal to df, whatever is the name of your data frame. We have chosen df dot ilog. Ilog means that you have to write down index here. If you will use log function, then you have to write down the name of the columns. right? Or name of the labels. Here index. So see here colon, and before colon I did not mention anything. It means all the records. I need all the records. We have 12 records, and then comma, and which column we are looking for? Zero. Zero means experience. The second one shows which we need it here, and the last one means that which we do not want. So the salary index is 1. I am going to execute, so you can see only the experiences there: 1 year, 2 year, 3 year. And see x-axis, there are two square bracket. It means this is 2D array. Now we want y-axis, so again same thing, y is equal to df I log all the records we want. For the second shows which column we need, so the index of the salary column is 1. So here just see here, and keep in mind, because we have to use later in our next lesson as well, that this is 1 square. It means it is 1D array. X-axis is on 2D array, y is 1D array. If you want to check the data type, so here df.data type, both data types are integer. That is great. Now is the point, here we have to import SVR. So you have to write down exactly same from sklearn.svm, means from support vector machine we have to import support vector regressor, and then we have to make the object of this class. So SVR, whatever name, I will highly recommend the name should be meaningful. SV means support vector regressor. I have given the name to this object. So SVR, and here by default, if you want, you can write down, but if you will not write down, by default the kernel is RBF. What kernel means? Kernel transform low definition data into high definition data, right? Then step is to fit, and all these steps, see, I will show you one more time. I have written here, first you have to import this, then object, then fit. After this we will work on predict, score, and graph. So come back to our original data. This is the fit. See, here I am not using train test split. If you will divide your data in train test split, then you have to write down x train and y train here. Otherwise, if you are not going to use train test split, then only x and y is fine. I am whatever the name of your variable, these are all the parameters. So you can say the kernel RBF is by default, right? Okay, now why I have written this y, I will show you. Now everything is okay. We want to visualize our data with the help of graph. So plt.scatter, we want the graph between x and y axis. Color is blue, marker is D. If you want, you can write down the complete spelling or change the color, whatever. Plot x, and then see SVReg dot predict. This is the predict function, and we are going to predict with the respect of x-axis. That is why I have written here, whatever coding you will write, each and every point should be clear, right? So we are predicting with respect to x, and these are our labels. So when I will execute it, you will see SVR support vector regressor is the title. This is the y-axis, this is the x-axis, and our graph is like this, which is not good. See here, our data points, actual data points are here. It should be in the form of arc, right? Because this is non-linear data, but we get the horizontal straight line. Now what is the problem here? Okay, first I will show you the score. See, sv.reg.score. So the score of this model is so poor. That is why, see, whenever we will predict any value, so if I will say, if we have an experience of 12 years, what the system will predict now, 2002, 2251 salary, which is totally wrong. Here you can see, the if we have the experience of 12 years, the salary is 7500. See here, this and this. For 11 years we have 6000. You can try now, it will give you the wrong, because see, the model is negative zero point 0.1, which is totally wrong. Now what is how to solve this issue? To solve this issue, we need transformation of data. So what is the meaning of transformation of data? We transform our data, whatever values we have for x-axis and y-axis, we transform between -1 2 plus 1, all these values. Right, how to do it? See, I told you that we have to import a standard scalar. A standard scalar transform the values between -1 to +1. So this is the standard scalar from sklearn dot pre-processing import a standard scalar. Now we have to create the object of this standard scalar, and I said x underscore sc, means this is for the x-axis, this is for the y-axis. And then x is equal to, after object we have to fit x underscore, see this one, this variable dot fit, and then transform, fit underscore transform x, means whatever values we have on x, we have experience, so experience, it will transform between -1 to +1. Same thing, now we have to create one more object for y, and then we have to fit this y, see transform. Here you can ask that why I did not write here. See, for the x-axis I just wrote, or I just mentioned x, but here I have written np dot reshape y. So now I will give you homework here, just delete all this and here write down y in this parenthesis, execute it. It will give you the error. It will ask you that y-axis is not a 2D array, it is 1D array. Remember I showed you in the beginning, I will show you again one more time. That is why you have to reshape y-axis. So np dot reshape, np for numpy, right? Y, and here you have to mention that we have 12 records and the first index. This is the important thing. I'm going to copy this. So where I am going to paste here, I will paste it here. Okay, as I said, I will show you. So see here one more time. I told you that keep in mind this one is the 1D array and x-axis is 2D array. That is why we have to reshape this one. When I am going to execute it, it will give us warning. That is fine, that we have converted to standard scalar. That is fine. Again, you have to run this, right? I am going to run this warning, no worries at all. Now, so why I have written this, as I said, that because of this coding we are going to transform our data between -1 to +1. So now I will check my y, right? Y is the salary, so salary is C here. If I will make it x, because we have transformed our data between -1 to +1. So here now everything is same. I am going to run this. So see, this time our plot is good. So in SVR algorithm, keep in mind that we have to transform our data, right? Then you will get this line. But still see, some points are not on the line. It is okay. It does not give us 100% accurate result. So see, now I'm going to check the score again. Again is 95%. If I will check for 12 years experience, see, as I have converted my data to standard scalar, that is why it is showing here. Now, if you need your data back to the original 1000 values, then you have to write down this coding. I will show you this one here. See, again same thing, np dot reshape I need for 12 and 1, so it is between -1 and +1. So y underscore sc dot inverse underscore transform, we did transform last time, now we are using inverse function. And sv dot reg, this is our data frame name or variable name, dot predict with respect to x. So you have to write down transform np array, exactly same what I have written here. So this is the my predict variable. When I will run this, so you will see now 6060, which is good, right? Because our score is 95%, but actually at 12 years experience, right, 12-year experience, we have 7500, salary is 7500, but this is predicting 6000 something. That is fine. right? So this is all about SVR. So keep in mind in SVR, we have to import SVR as well as standard scalar. If someone will ask you why we have to import a standard scalar, because we have to transform our x-axis and y-axis values between -1 to +1. I hope the concept is clear. So please practice it. If you have any questions, you can ask me. Subscribe to my channel, and thanks for watching.